This tutorial explains how to answer questions such as 250 centimeters cubed of sodium hydroxide reacts with 500 centimeters cubed of 0.1 moles per decimeter cubed sulfuric acid. What is the concentration of a sodium hydroxide? So we'll start with a slightly easier question. What is the concentration of a solution of sodium hydroxide if 12 decimeters cubed of it react with exactly 6 moles of hydrochloric acid? So firstly, let's visualize our moles of hydrochloric acid, like so. So the next thing we need to think about is moles of sodium hydroxide. For this, what we could do with is a balanced symbol equation. So the equation tells us at the bottom, 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. If we have 6 moles of hydrochloric acid, it will react with 6 moles of sodium hydroxide. So we've got 6 moles of hydrochloric acid, and this is in 6 decimeters cubed. So that's trying to represent visually 12 decimeters cubed. Concentration is obviously equal to moles divided by volume. We've got 6 moles divided by 12 decimeters cubed, giving us a concentration of 0.5 moles per decimeter cubed. Here's another question, slightly different. The difference here is it now is mentioning 6 moles of sulfuric acid, and it's 6 moles of sulfuric acid reacting with some sodium hydroxide, and there is 12 decimeters cubed of sodium hydroxide. So let's break it down. Let's visualize our 6 moles of sulfuric acid. We now need to think about how many moles of sodium hydroxide it reacts with. So this is where we want the equation. If we have 6 moles of sulfuric acid, it will react with twice the amount of number of moles of sodium hydroxide, so it will react with 12 moles of sodium hydroxide. Our 12 moles of sodium hydroxide volume of sodium hydroxide is 12 decimeters cubed. So if we take the 12 moles of sodium hydroxide, the 12 moles of sodium hydroxide are in 12 decimeters cubed. So concentration is going to be equal to number of moles, 12, divided by 12 decimeters cubed, giving us a concentration of 1 mole per decimeter cubed. What's the concentration of sodium hydroxide if 6 decimeters cubed of it react with 3 decimeters cubed of 2 moles per decimeter cubed of hydrochloric acid? I always think it's probably worth underlining that because that's going to include our first concentration calculation. So let's visualize everything. We've got 3 decimeters cubed, each blue block's representing a decimeter cubed, with a concentration of 2 moles per decimeter cubed. We now need to work out the number of moles of sodium hydroxide. So this is where we will need our equation. And we know that 1 mole of hydrochloric acid at the bottom will react with 1 mole of sodium hydroxide. We can see here visually we have 6 moles of hydrochloric acid. So it will react with 6 moles of sodium hydroxide. It tells us the volume of the sodium hydroxide is 6. So that all 6 moles will be divided among 6 decimeters cubed. So the concentration will be 1 mole per decimeter cubed. Concentration is moles over volume, giving us an answer of 1 mole per decimeter cubed. Here's another question. What's going to be the concentration of sodium hydroxide if 10 decimeters cubed of it reacts with 5 decimeters cubed of 2 moles per decimeter cubed of sulfuric acid? Again, the first thing normally to do is find something you know the concentration and volume for. So the number of moles of sulfuric acid, again, it's 5 decimeters cubed, each decimeter cubed containing 2 moles. So we can see moles is equal to concentration, 2 times 2 moles per decimeter cubed times the volume times 5 decimeters cubed, giving us, in fact, we've clearly got 10 moles of sulfuric acid. To work out the number of moles of sodium hydroxide, we need to have our equation. If we have 10 moles of sulfuric acid, we will have twice that number of moles of sodium hydroxide. So that's visualizing 20 moles of sodium hydroxide. We now need to think about what volume we've got of sodium hydroxide. Here is a diagram representing 10 decimeters cubed. All 20 moles of sodium hydroxide need to be spread evenly amongst all 10 decimeters cubed. So you calculate the concentration of sodium hydroxide, doing moles divided by volume, giving us our concentration, of 2 moles per decimeter cubed. What's the concentration of a solution of sodium hydroxide if 6 decimeters cubed of it reacts with exactly 4 decimeters cubed or 4 moles per decimeter cubed of hydrochloric acid? So again, what we can do is we can work out how many moles of hydrochloric acid we've got, doing concentration times volume. So we've got 6 times 4, so 24 moles of hydrochloric acid. The number of moles of sodium hydroxide, we need to obviously write down the equation. The equations will be given to you. And we can see that if we have 24 moles of hydrochloric acid, we'll have 24 moles of sodium hydroxide. The volume of hydrochloric acid is given in the question, 6 decimeters cubed. So concentration is moles divided by volume. So 24 divided by 6 gives us a concentration of 4 moles per decimeter cubed, like so. What volume of a solution of sodium hydroxide of concentration 2 moles per decimeter cubed is required to react with a solution which contains 3 moles of sulfuric acid? So the first thing is it tells us already the number of moles of sulfuric acid, so we need to think about how many moles of sodium hydroxide it will react with. We obviously can write the equation down, which relates the number of moles of sulfuric acid to moles of sodium hydroxide. So for every mole of sulfuric acid, it will react with 2 moles of sodium hydroxide. So we have 6 moles of sodium hydroxide. It tells us the concentration of sulfuric acid is 2 moles per decimeter cubed. So if we visualize it, concentration of sodium hydroxide is 2 moles per decimeter cubed. Now, we've got a concentration. We can see 1 decimeter cubed has 2 moles in it, and we've got a total of 6 moles. So what we're going to clearly need is 3 decimeters cubed. We need 3 decimeters cubed because we've got 6 moles of sodium hydroxide. Again, we could also just use the equation. Volume is equal to moles divided by concentration. So 6 divided by 2, giving us 3 moles per decimeter cubed. Again, if we just imagine it, if you learn the equation, concentration is moles divided by volume. We can rearrange this equation to get volume is moles divided by concentration. If we have a slightly modified version of the question, and it says what volume in centimeters cubed is required of the same thing, we just merely need to times it by 1,000 to convert decimeters cubed to centimeters cubed. We're getting a bit close to the actual sort of questions. What volume in centimeters cubed of a solution with 1 mole per decimeter cubed of sulfuric acid is required to react with 4 decimeters cubed of 0.5 moles per decimeter cubed sodium hydroxide? So firstly, we could work out the number of moles of sodium hydroxide. We can see here the units here and here are both in decimeters cubed, so we don't need to do anything particularly complicated. We've got a concentration of half a mole of sodium hydroxide per decimeter cubed, and we've got 4 decimeters cubed. So we can see we've got 2 moles of it. Again, you could just do number of moles is equal to concentration times volume. So concentration 0.5 times by volume 4. Again, we don't need to divide by 1,000 because it's already in decimeters cubed. So that gives us 2 moles of NaOH. So we could write 2 mole of NaOH. Moles of sulfuric acid. If we write the equation down, we've got 2 moles of this. So looking at the equation, for every 2 moles of sodium hydroxide, it would have been formed from 1 mole, so it would have reacted rather with 1 mole of sulfuric acid. So we've got 1 mole of sulfuric acid. It says what volume in centimeters cubed, so important to highlight the centimeters cubed, of 1 mole per sulfuric acid will react with this. Now, we've worked out the number of moles is 1 because we've got 1 mole of sulfuric acid. If we know the equation for concentration is moles divided by volume. We can rearrange this so that we can say volume is equal to number of moles divided by concentration. Number of moles is 1. Concentration is 1, which is given in the question here. So 1 divided by 1 gives us 1 dm cubed. What volume is this going to be? In centimeters cubed, that's 1,000 centimeters. 250 centimeters cubed of sodium hydroxide reacts with 500 centimeters cubed of 0.1 mole per decimeter cubed sulfuric acid. Now, we can see in the question, one which we know a volume and a concentration for, is the sulfuric acid. What we don't know is the concentration of the sulfuric acid. And what it's trying to show here are the pictures of what you might have done if you've done the reaction. Here is a picture showing your 250 centimeters cubed of sodium hydroxide and the mystery concentration. And then what was given or put into it or titrated it with was 500 centimeters cubed of a solution of 0.1 moles per decimeter cubed of sulfuric acid. So the first stage is work out the number of moles present in the substance with known concentration and volume. So what's the number of moles of sulfuric acid? Moles is equal to concentration times volume. So concentration times volume in decimeters cubed gives me 0.05 moles. Write the equation. You will always be given the equation. So we can see from the equation, if we have 0.05 moles of sulfuric acid, it will react with twice the number of moles of sodium hydroxide. So we've got 2 moles of sodium hydroxide. If we had 1 mole of sulfuric acid, however, we only have 0.05 moles of sulfuric acid, so it will react with 0.1 moles of sodium hydroxide. Next stage, work out the concentration of a substance with unknown concentration. What's the concentration of a sodium hydroxide in moles per decimeter cubed? Concentration is equal to moles divided by volume in centimeters cubed. So concentration, moles divided by volume, giving us 0.4 moles per decimeters cubed.